Oh, hi guys. I was just looking up at the moon in our Sky Dome at the Cerritos Library. The moon is our next topic for our Universe of Learning virtual program. There are many ways we can observe the moon. You can just look up and see how nice it looks in the night sky. You can use binoculars like these, or even use a NASA telescope. That's right, you can use NASA's Microobservatoryorg's robotic telescopes to request photos of the moon, planets, and other nebula. Let me walk you through it. First, go to Microobservatoryorg. Click on Observing with NASA. Once it pulls up the Observing with NASA page, click on the tab that says Control Telescopes in the top left corner. It will then pull up a page that says Select Your Target. Here, you can select planets, galaxies, and nebulas, and of course, our moon. Click on the Observe button of what you want to view with the remote telescopes. This will then take you to the Adjust Your Telescope setting page to choose how you want to see your image. You will select your field view, exposure time, and a filter when you click in the box. It will also suggest the best settings for your image. Next, we have the Provide Your Contact Information page. This is where you need your parents' permission to fill out the information to receive your requested image. This is my image of the moon that was emailed to me. You can go back to the Observing with NASA page and click on the Tools and Resources tab to use a special software and filters to create your own astrophoto of your image. Now, let's find out some facts about the moon from our book, Luna, The Science and Stories of Our Moon by David A. Aguilar. The moon has been a constant companion to Earth. From the beginning, early humans have marveled at it, changing phases, and watched it trace a path across the sky. Today, we know that the moon is a natural satellite with no atmosphere or flowing water on its surface to support life. It's 1/4 the size of Earth and located some 239,000 miles away. A modern spacecraft can reach the moon in about 3 days. The evolution of the moon has been a long process. In its infancy, our new moon was just a collection of bits of rock. Captured by Earth's newly expanded gravitational field, the debris spread out into a delicate ring structure. This debris orbiting the Earth continued to collide and weld together, steadily growing to form our moon. The next few billion years brought more impacts, followed by volcanic activity that gushed dark molten lava onto the side of the moon facing Earth. The moon's surface cooled and became the way it looks today. Earth takes about 24 hours to complete the rotation on its axis. This is about the same time it takes the moon to complete one orbit around our planet. As a result of this close synchronization, one side of the moon always faces toward Earth, while the far side remains hidden from view. This synchronization is called tidal walking. The dark side or far side of the moon does actually experience just as much sunlight shining down on it as the near side facing Earth. We just don't see it. As the Russian Luna 3 spacecraft orbited the moon in 1959, it discovered that the far side of the moon looks very different from the near side. There are no flat dark plains in the far side. It is covered with impact craters, creating a rough, chaotic terrain. This photo shows the first photo of the far side of the moon by Luna 3 with composite images created by the Lunar Reconnaissance Orbiter in June 2009. The sun appears circular in the daytime sky, but the moon's shape continuously changes, looking different from one evening to the next. Now, these changes, however, always appear in a predictable pattern, known as the phases of the moon. The moon does not change its physical shape throughout the month. What changes is the part of the moon illuminated by the sun that we are able to see. As the moon circles the Earth, in orbit that takes 27.3 days, only half of the moon is fully illuminated at any time. As Earth travels on its own path around the sun, it moves slightly faster than the moon. The amount of lunar surface we see is the result of the moon's position in relation to Earth and the sun. There are 8 designated phases that the moon goes through. The shapes it takes are caused by its location to the sun and where people are on Earth. The first phase is the darkened new moon. This phase happens when the moon is situated between Earth and the sun. This phase is invisible to us on Earth. Following the new moon, a thin waxing crescent suddenly appears. This is the second phase. The word waxing is a term that describes something that is growing in size. As the waxing moon grows brighter, it enters the third phase, named the first quarter moon. The fourth phase is a waxing gibbous, which continues to grow until it reaches the fifth phase. The fifth phase is the full moon. It takes about 14 days for it to go from the new moon to a full moon. After the moon reaches its full moon phase, it then enters its waning, shrinking phases. This is the waning gibbous phase. In each phase, it shrinks, growing dimmer over the next 14 days. This is the third or last quarter phase. Then it reaches the waning crescent moon phase. This is the last phase before another new moon appears. Depending on how clear the sky is during the waxing and waning crescent phase, sharp eyes can detect a faint outline of the hidden full moon behind the brightly glowing crescent. The faint outline may even appear blue. The bright crescent is being illuminated by the sun. But what is illuminating the dark side that should cast in a black shadow? The light is coming from Earth. Sunlight from Earth bounces off our oceans and white cloud tops back onto the surface of the moon's dark side. This phenomenon is called Earthshine. In addition to illuminating the night sky, the moon affects the Earth in more dramatic ways. Combined with Earth's rotation, the gravitational pull off the moon and sun on Earth causes landmasses located near the equator to bulge. However, you likely won't notice. The change is too small to see. We are much more familiar with the effect the sun and moon have on our oceans. Their combined gravitational forces cause the oceans' daily rise and fall, referred to as high and low tide. Typically, high and low tides occur twice in a 24-hour period. In open oceans, the average range in tidal change is 3 feet. Coastal tidal ranges can change significantly depending on the shape of the shoreline, the ocean bottom, and the volume of water located directly offshore. For example, in the Mediterranean Sea, where coastal shorelines are very shallow, we don't find much difference in the height of the tides. Thousands of miles away, the world's most dramatic and largest tidal range occurs in the Bay of Fundy in Canada. In just 6 hours, the water levels can drop and rise a staggering 50 feet in height. Predicting changes in tides is important for a variety of people, from sports enthusiasts to commercial fishers whose livelihoods depend on the ocean. Large ships navigating through shallow ports or intercoastal waterways need to plan their schedules. Luckily, tides follow predictable patterns, and tide tables reliably provide this critical information. There are a few times a year, though, when tides behave differently. When the sun, moon, and Earth are all aligned, tides do something pretty neat. On one side of Earth, the moon's strong gravitational force pulls at the oceans, causing the water to surge outward toward the moon. At the same time, on the opposite side of Earth, the sun tugs on the Earth's water, causing it to surge toward the sun. When this happens, scientists call it a spring tide because the waters seem to spring away from Earth. You can see spring tides in action off the coast of California. Here, extreme high and low tidal changes can approach 7 feet during spring tides, compared to only about 2.5 feet the rest of the year. Other times when the sun, Earth, and moon are at the right angles to each other, their gravitational forces are spread out, resulting in much smaller shifts in water levels. These are called neap tides. Now let's talk about lunar eclipses. There are 3 basic types of lunar eclipse. The first, penumbral, occurs when the full moon passes through the faint outer edges of Earth's shadow. The second, a partial lunar eclipse, occurs when part of the moon phases through Earth's darker central shadow. Then we have total lunar eclipses. This is the most spectacular type. It occurs when the full moon passes directly through the center of Earth's shadow, resulting in a dramatic change to the moon's appearance. This rare event transforms the moon into a vibrant rust red orb in the sky. Solar eclipses, like lunar eclipses, occur as a result of the alignment of the Earth, sun, and moon. Yet solar eclipses are so rare that you would be lucky to see one in your lifetime. These events only occur when a new moon passes between Earth and the sun. In a total solar eclipse, the moon, sun, and Earth are exactly lined up. When that happens, the moon completely blocks our view of the sun. The sky turns dark and the sun is hidden from sight. The moon has many geological features. The first is called Mare. When viewing these large flat expanses, early astronomers thought they were seeing water on the moon. So they named these areas Mare, which is Latin for seas. Today we know that Mare is a large, flat volcanic plain, and together, all the Mareas cover about 1/5 of the lunar surface facing Earth. On Earth, mountains are created by lava flowing out of volcanoes or large plates of rock crashing into each other. On the Moon, mountains form when asteroids or large meteorites smash into the ground. These impacts toss around debris, creating mountain ranges or montes. The tallest mountain, or mons, on the Moon is Mons Hygens. It is 3.4 miles high. By comparison, Mount Everest on Earth is 5.5 miles high. Rill are another feature that can be found on the Moon. Rill is a German word that means groove. On the Moon, rills are long, narrow valleys that look like dried up riverbeds. But instead of water, it was lava that cut these snake-like channels. Our next feature, rays, are the result of light-colored dust and rock being blasted out of craters and then gently settling back down onto the lunar surface. They resemble the thin spokes of a wheel radiating out from the hub. Craters with rays are young craters, sometimes no more than a few 100 million years old. Craters are cup-shaped holes in the ground that are formed by impacts from asteroids or other space debris. They range in size from microscopic to 180 miles in diameter. The smallest craters you can see with an amateur telescope are about 2 to 3 miles in diameter. Large craters are labeled as walled plains or ringed plains. Walled plains are large, smooth-floored craters surrounded by low, circular walls with no central peaks sticking up in the center. They can range in size from 37 to 180 miles in diameter. Ringed plains are deeper craters that have floors sometimes jumbled with debris. A ringed plain may also have a sharp-pointed peak poking up from the center, caused by the ground rebounding during the impact that caused the crater. Steep walls, shaped like steps, surround these craters' edges. When the Apollo astronauts landed on the Moon, they found themselves in another world. With no atmosphere to pass along sound waves, it was silent. There was no weather, wind, or clouds. Overhead, the sun blazed brightly in the pitch-black sky. Without an atmosphere, temperatures on the Moon vary dramatically. Imagine moving around on a surface that can reach 273 degrees Fahrenheit in sunlight and minus 245 degrees Fahrenheit in the shade. Also, on the Moon, with no air to scatter the light, all shadow appear pitch black, making it impossible to tell what's hidden by them. The Apollo astronauts found the Moon a dusty place that smelled like wet ashes or gunpowder. Yet, unlike Earth's smooth, weathered, and eroded dust, moon dust is full of tiny, sharp rocks. These pieces were chipped off the lunar surface by micrometeorites hitting larger boulders. Each piece of dust is a spiky, barbed shard that could cause damage to your lungs if you were to accidentally breathe it in. Lunar dust was crucial to one of Apollo's main missions, to learn how the Moon was formed. Comparing soil samples collected on the Moon with samples from Earth, researchers found some similarities. Yet, there were also enough differences to indicate that materials from other sources had been mixed in. This evidence proved that a collision between Earth and another object had created the Moon. Now that you have learned some interesting facts about our Moon, you can join with hundreds of people around the world and observe the Moon on September 26, 2020, and celebrate International Observe the Moon Night. For more information, you can go to our website for the link. Now, stay tuned for Ms. Rochelle as she shows you how to keep a moon observation journal and make your own moon facecraft. Thank you so much and enjoy!
Hello, welcome to the Cerritos Library. My name is Ms. Rochelle. Today we'll be creating a moon facecraft and I'll provide directions on how to complete the moon observation journal. Join me in the art studio and we'll get started. The materials you'll need for this craft are a paper plate, black paint and paintbrush, glue, yarn, scissors, single hole punch, 3.5 and 1.5 inch circular templates, pencil, blue and green markers, black and white construction paper, and a diagram you could find by going to cerritoslibrary.us, click on the Cerritos Library Universe of Learning Virtual Programs link. From there, click on the link for the Moon program. The first step will be cutting out a circle in the plate right in the middle. Once you do that, you'll have this. After you cut the circle out of your plate, you're going to take the single hole punch and punch 6 holes evenly spaced. After you punch 6 holes, you're going to flip the plate over and paint it black and set it aside to dry. Next, you'll use the 3.5-inch template and trace it. And this is what we're going to use to create the Earth. After you have it cut out, you're going to use a single hole punch and cut out 6 holes. After that, you're going to use your blue and green markers and color it to make it look like the Earth. Next, we'll use the yarn to attach both pieces together. And keep stringing it through till you get all 6 holes attached. Next, we'll take the 1.5-inch circular template and we'll have to cut out 7 black circles and 7 white circles. And after you do 7 white circles and 7 black circles, you have this. Then we're going to use our diagram to create all the different phases. First, we're going to start with the first quarter. So you can take the black and cut it in half. Use our glue. Then we're going to glue it on. Then we're going to do one for each of the different phases. After you cut out each one, you'll have all the different phases for the moon. Then we'll use this. And then we're going to put each different phase onto the craft. So right here we have first quarter, waxing gibbous, full moon, waning gibbous, last quarter, waning crescent, new moon, waxing crescent. Now your craft is complete. A fun way to keep track of the different moon phases is by using the Moon Observation Journal. You can get this journal by going to cerritoslibrary.us, click on the Cerritos Library Universe of Learning Virtual Programs link. From there, you click on the link for the Moon program where you can locate this journal. For your Moon Observation Journal, you will observe the moon each night around the same time and use a pencil to shade in the different phases of the moon for each day. Once you do that for a week or so, you can print out the questions and answer the questions about what you observe by looking at the moon each day. You can also locate informational facts about the moon through our website. I hope you enjoyed our presentation on the moon. See you next time.